Okay, so in this lesson, we're going to be talking about some different relationship with tangent lines. Before we do that, though, I want to review real quick these three vocabulary in particular. We're just being able to identify them in a picture. So go ahead and look at this picture to the right here. We have three different segments. We've got this little one right here, this line, excuse me, on the outside, and then this one right here. I want you to identify which one is the radius, which one is a tangent line. Remember, tangent touches. And which one is a chord. Go ahead and look back over your vocab from the first few lessons. See if you can identify which is which. Okay, so the radius is from the center of the circle to the outside. So this is BA. Radius, or AB, same thing. Center to the outside, that's the radius. Tangent touches. So this line touches the circle right here at B. So we can call this line BC. That is the tangent line. It touches the circle at one point. So that leaves DE to be the chord. Remember that a chord is nothing really special. It just connects two lines on, 2 points on the circle, and that's it. Any 2 points, connect them. We call that a chord. So here's where we come into the new information now. First, we're going to be talking about tangents and radii. That's radius plural. Let's do that. Well, this is what we're going to work with to start with today. A tangent is always perpendicular to the radius of a circle. So this was the picture we had right here. Here's my tangent, and here's my radius. They are perpendicular. If we recall way back when, what type of angle do perpendicular lines make? They make a right angle. Perpendicular means we have a right angle where they intersect. So a right angle is right there. Where they touch, we have a right angle. That's perpendicular. Now, what we learned in the last unit was that right angles are special with triangles. So we can prove if a line is a tangent, which is what we're going to do. They're going to ask, is this line tangent to the circle? By using Pythagorean theorem, a squared plus b squared equals c squared, because that only works for a right triangle. That only ends up where a squared plus b squared actually does equal c squared. Now, the one thing I need you guys to be careful about when you do these questions is, again, with a squared, b squared, c squared, remember that c, in this case, we'll be able to do it this way. C has to be the largest side, if you want to make a note here. But if we can't tell if it's the largest side, we can, for example, we can only tell if it's the largest side if we know all three sides. If we don't know all three sides, we don't know if it's the largest side. But it's also across from the right angle. Remember, it's the hypotenuse. Across from the right angle. If you want to also write hypotenuse down, you can. A and B are just the other two sides. C has to be the largest side across from the right angles. Let's go ahead and look at the first example here. So let's label our picture. We are given that DE is 17, DF is 15, and EF is 8. Take a moment, draw this picture, and label those side lengths. Okay, so we have 17, 15 for DF, and 8. We want to verify whether or not it is a tangent. So if DF, notice that DF is the one that's touching at one point. Remember, touching does not mean cross through. Yes, DE technically only touches the circle here at one point, but it's crossing through. A tangent just like grazes the circle. So this is the line we're checking to see if it's a tangent. It is a tangent if there is a right angle right here. And we can prove if there would be a right angle by using Pythagorean theorem, as that only works when we have right angles. If it doesn't work, then this isn't a tangent. So we're going to do something very similar here, where we're going to compare. I'm going to go ahead and keep this the same way as we've been doing it. We're going to compare c squared and a squared plus b squared. Sorry, I'm trying to use my finger here. It's not working out very well. Oh, for Pete's sake, that's an A. That's a square. There we go. That's a plus. Okay, I just gotta use my mouse, I guess. Lost my stylus a while back. So this should look very similar. We've done this before when trying to show if something is a right triangle or not. Now, in this case, though, the nice thing is if they're not equal on both sides, all we have to say is no. That's it. We don't have to say, oh, it's less than, so it's acute, it's greater than, it's obtuse. We don't have to say that. If c squared does not equal whatever on this side, we just say no. If they are equal, we say yes, they are, df is a tangent. So looking at our options here, 17, 15, and 8, which one has to be C based on what we just said? 17 has to be C. And then 8 and 15, it doesn't matter. I can call this A and B, or I can switch them. You're gonna get the same thing. Let's go ahead and plug this in. Now again, 17 is C, but here we have 17 squared. Be careful with that. And then I have 15 squared plus 8 squared. So all I'm going to do is use my calculator, check on both sides what I get. Oops, 17 squared is 289. And I'm going to go ahead and plug this whole thing in. So 15 squared plus 8 squared. I'm doing the whole thing. Hey, this gives me 289. So because they are equal, what that means is there is a right angle right here. And we can say, yes, DF is then a tangent line. It's guaranteed to touch the circle at one point since there's a right angle. Because touching the circle at one point is like a very, very small point. It just grazes. So looking at a picture, we can say, well, yeah, it looks like it only touches at one point. It's possible it doesn't because we can't zoom in super close right there to see if it actually does only touch at one point. So this proves to us, yes, this is a tangent line. So I want you to try this one. Go ahead and draw the picture, label the information, and then we'll pause there and come back and then go from there. Okay, so OC is 5. CD is 12 and OD is 14. Now again, that's all of this, right? So we are once again going to compare C squared and A squared plus B squared. Go ahead and try this one. Again, being careful, which one has to be C? We have to be very careful which one is the C. Okay, so C has to be the 14 because that's the biggest side. And we've got 5 squared plus 12 squared. So let's plug this in. We got 14 squared is 196. And we have 5 squared plus 12 squared is 169. So is CD going to be a tangent line then? Nope. Since these are not equal, we can just say nope. It's not a tangent, even though in the picture we drew it so it looks like one. If this were an actual circle and these lines had these actual measurements in real life, it wouldn't touch at one point. It might end up cutting through the circle and touching it too. Again, tangent just barely grazes by the circle. That only works if we have a right angle here. And we have just proven there's not going to be a right angle. So no, not tangent. Okay, there is one more. Oh man, I really forgot to fill this stuff in. That's okay. Doesn't necessarily matter. You're copying it all. So we have one more relationship we're talking about. We're going to start off easy here, and then we'll do some harder stuff together. So now we're talking about tangents and chords. So this is a picture we're looking at here. See, this is a chord and not a radius, because a radius goes from the center to the outside, and this goes from 2 outside points. This is a chord. This little one right here was a radius. I want you guys to make sure you understand the difference. So we have the same relationship as inscribed angles that we were working with on Friday, that angle equals half the arc. So remember that central angles is a different relationship. Here, we're going to have angle equals half the arc. So what that means is when we have this chord intersecting with this tangent, notice they create 2 angles, right? Right there. So that angle is going to be, I'm going to use some color actually here. This angle is going to be half of the arc it opens up to. So notice it opens up to this arc, whereas this one, this angle, opens up to this arc. So remember, we have the big old arc coming down to a little baby angle. The angle is going to have to be the smaller one. So always double check your answer. Remember that you will either double your answer or take half. You either multiply by 2 or divide by 2. How you know is ask yourself which one needs to be bigger or which one needs to be smaller, right? So let's look at this question. It says given that AD is a tangent, so we know that, and we have the measure of BC. I'm going to go ahead and erase this. Now be careful, this is an arc. So take a moment and try and draw that picture and label where we would put the 124. So this is an arc, so that's this right here. Arc BC, it's not an angle. We are trying to find the measure of D to B to C. So notice this angle opens up to that arc. So ask yourself, we have the big open arc and little baby angle. If we're trying to find the angle, should I multiply by 2 or divide by 2? Think about it for a second and try it. Well, since I'm trying to find the angle and I have the arc, I'm going to divide by 2. You guys should know by now, you're old enough, that dividing by 2 is the same as multiplying by a half. So that's why it says half the arc here. We know dividing by 2 is the same thing. Because again, I have the big arc, I want the small angle, my answer should be smaller. So I'm going to take 124 and divide by 2. If you did 124 times a half, you're going to get the same thing. So that's going to be what, 62? And there's our answer. And that's correct. We can look at our picture here. We have the big arc. The angle is smaller. We did this correct. Big open arc down to a little baby angle. Keep that in mind for how you know which one needs to be bigger and which one should be smaller. Okay, we're going to try the exact same thing here. I want you to do the whole thing. Look at what we are given. Is it an angle or an arc? And what are we trying to find? Is it an angle or an arc? Should I multiply by 2? Should I divide by 2? Do I need to get bigger or do I need to get smaller? Go ahead and try this one all the way through. Okay, so I know RPN. So following with the pen very carefully, R to P to N, I know this is 74 degrees. And I am trying to find the measure of arc. Pay attention to those, PN. Well, notice again that that angle opens up to that arc. When we say angle equals half the arc, we specifically mean the arc that the angle opens up to. I'm not referring, if I have this angle here, I'm not referring to this arc when I say angle equals half the arc. I'm referring to the fact that it opens up, here's my angle, it opens up to that arc. So if angle equals half the arc, we have a big open arc and a little small angle. Should we multiply by 2 or divide by 2? Multiply by 2. We are trying to get bigger to get out here, right? Again, if the angle is half the arc, we would double the angle to get the arc. So 74 times 2, that's going to be 148. It should be. Yep. So the arc is 148 degrees. So that's going to be this measure right here, 148 degrees. So we're going to practice this a bit more in class because these problems get a bit trickier. The tangent problems really don't get any trickier than that. But these ones do get a little tricky. So we're going to practice some more in class.